Hello everyone. Good morning, good afternoon, whatever it might be. This week in the physics lab, you're going to do an experiment involving friction, and something that's going to help you out with that is some software called Data Studio, which we haven't used yet, and I thought it would be neat to introduce it to you through this little lecture. So let's get started. On my desktop, Data Studio is a little icon. When you go into the lab, I believe you're gonna go into here. You're gonna do all programs, and when you go down here, you're actually gonna find it right here. And if you click on it, you'll go down and you can hit Data Studio, and this will fire up. When you get here, you can just hit Create Experiment. And here we are. Now, if when you fire up your computer, this doesn't look like this, it actually has a little yellow thing and it says you're not connected, there's a few things that you might have to do. I had to fiddle with mine a little bit, and earlier yesterday I had to do a little fiddling in the computer lab, so this may not be as seamless as it looks here. One thing you can do if you have some problems, and again, if you see where it says click to disconnect, if that says click to connect, you can go over, choose interface, and select the 500 interface and say OK. Clearly I'm OK. But anyhow, if this is yellow and you can't fix it right away, call myself over or one of the TAs, and we can probably fix that for you. You should notice that on your table you actually see this interface box. This is a 500 interface box. In fact, I've got a picture here to show you what it looks like. There it is. There's the laptop computer that everybody has. That's the interface box. And hooked to it, this is a force sensor which you're going to use. Some of you have a slightly different model that's just a little bit longer. But notice where it hooks. These inputs here are what are called the analog inputs, and these two are the digital. This force sensor, which again obviously measures force, goes into the analog one, and we'll hook it right into the very first one. Yeah, you could use any of them, but we'll use that one there. But that's what your setup is going to look like. You'll notice this cable here, this actually carries the signal from this interface box over to the computer. This thing really is the sort of go-between between the computer and the sensor. It allows the computer to make sense of what this does. So I'll just close that. Now notice here in the kind of the icon that you see, the picture that you see on the computer, there's nothing hooked there. Well, what you can do is if you put your mouse there and hit the leftmost key, it'll bring up the options of sensors that you can hook in there. And I'm going to go down, and we want to pick force sensor, which is this one here. It's actually not the student one. We'll pick force sensor and hit OK. And there we go. And notice it's right below that, which again, if we go back to the picture, it corresponds to where it's physically hooked. You just have to be a little bit careful that you don't physically hook it to this one here, and then over here you sort of indicate it's hooked to this one. Bit of confusion. Not hard to deal with. When you do that, one thing you can do is you might want to bump up the sample rate just a little bit. This says you'll get 20 force data points every second, and that's going to be plenty. One of the things you have to do with a force sensor is you have to calibrate it, and that happens up here. You'll notice there's a button that says Calibrate Sensor. You'll click on that, and what you do, and you can't see this, and I'll demonstrate this in class, but what you do is you take two known weights. Maybe you'll take a 100-gram weight, which is actually 0.98 newtons. And what you'll do is you'll hang that weight from the force sensor And when it's hanging and it's stable, then you hit read from sensor. So you click this button. Then you take that weight off and you put on another one. Maybe you'll put on a 200 gram weight, which is 1.96 newtons. And then you hit read from sensor once it's suspended there. And that gives you, basically, computers only read voltages. You're interested in forces and newtons. You have to have some way of getting out what you want, which is forces, but also having the computer correctly read things in voltages. Now you don't have to do anything with these. These will be what they're going to be for the computer. But this simply allows you to have a correlation that if the computer reads so many volts, maybe 1 volt, you then have told it that, hey, 1 volt actually equals about 1 newton. Or concurrently, 3 or 4 volts is equal to maybe 3 or 4 newtons, something like that. They're not always in complete agreement. So you have to do this calibration, so that's something to keep in mind. And again, I'll go over it in class. But the reason you have to do it is that computers read voltages and you're interested in newtons, and you have to get some connection between the two. So again, I don't have weights here, and you can't see it anyway, so I won't go through it anymore. But just a reminder that you'll have to do that. So I'm just going to hit cancel. Now, a nice way to display your force data is if you go down here to the lower right. I guess this is the lower left. And hit graph. Connect on graph. And you can expand it. And notice you have a graph now of force versus time. And if I go up and if I hit the start button, notice this is giving me, actually I'm not doing anything with the force sensor right now, and it's reading 7 newtons. That's because I didn't calibrate it. But what I'm going to do right now, although you can't see this, I'm going to push on the force sensor and even pull on it. There's a little end where you can do the pushing and pulling. Let me show you a picture. Again, if I go, oh, I think I canceled out my picture. That's unfortunate. Any regard, you will see when you get the force sensor, there's a little, either a hook or a little rubber bumper that you can push or pull on, and that allows you to read your voltage. Now, a couple things that are neat that you can do, because right now what you see here is I've taken some data that gives me my force as a function of time. Again, it's a little bit crazy because it hasn't been calibrated. But as you can see, it looks like I'm running about 7 newtons of force. Then I pushed on it, and the force built up to almost 12 newtons, and then went down to a low of almost 2 newtons and changed around. If I want to get, maybe over this section here, I want to get an average. And that's something you're probably going to want to do during the experiment, which I haven't said anything about exactly what you're going to do, although it involves friction. But if you can simply put your mouse here, hold down the leftmost key, make a box, and it'll highlight. Again, what I've done, in fact, I can get rid of it by just clicking the leftmost button anywhere. But again, if I put my mouse over up here in the upper left-hand corner, hold down the leftmost key, and then just drag this across and highlight this, I can then go up to this little function tab here. And usually what I do is I go to show all. And notice what you get here. This will actually tell you what the minimum value is of this data set, which corresponds to here. And you can see it's actually just a little over 2. It's a little over 2. This tells me what the maximum is, right about here. Again, that looks about right. It's almost 11, or almost 12. And this is the average. And again, this could be this will be useful. The mean or the average is the average, obviously the average force value from here to here. Now, something you can do to make your graphs somewhat more appealing, dependent on the size of things, is you might want to move them around a little bit. I can take my mouse, if I put it right on top of a number, notice the mouse turns into the squiggly, hold down the leftmost key, and I can do this. I can actually expand or contract my axes. This is quite useful. If your data initially looked like this, You say, oh, that's awful small. I'm not using very much of the graph. I would go over here, put the most on the 10 or the 20, something like that. Hold down the leftmost key and expand it. And I might continue to do that. I can do the same with time. Put it on a number, and I can expand it out. Now, one thing, take this for example, I'm interested in this stuff over here, and maybe I'm not interested here. I can now put the most just on the axis where it turns into the hand, hold down the leftmost key, and I can move it over here like this. Same thing here, right here, and I can move it down. Now if I want, if I hit start, I can start collecting data again. Again, I'm pushing on the force sensor, the little bumper, the little hook. And again, start and stop. If for some reason I'm not happy, or I'm just playing around, I don't want this data, I can go up to experiment, and I can do either delete last data run or delete all data runs. I might delete all of them, and it'll ask if I want to remove them, and I can start again. Again, I can run it, and I can kind of move things around. Notice that the data is color-coded, which is good. If I stop and then I start, I have a new one. Now this one is green. I can stop this one, and if I want to do various things with it, again, I can select, go up here, select the red one. That means that when I do this business here, I'm highlighting the red stuff. If I want to click this off, if I want to go to the, say, the red one, or if I want to go to the green one, it'll switch. Now I can, with the yellow over the green one, I can now highlight the green, and it's giving me the numbers. Again, giving me the mean and the max and the minimum. And this will be quite useful. Other than that, I think that's a lot of the main stuff. If for some reason you want to go back to where you see the interface icon, you just hit setup, and you can go back to here, because you might want to calibrate. In fact, more than might, you most likely will want to calibrate a few times today, because these force sensors, when you calibrate them, the calibration can change over time. So you go back to here and hit calibrate, and again, go right in here. The numbers that you had originally put in there should still be there. You just have to put the weights on again and hit read from sensor. Same with down here, put the new value on. Again, I will clarify that on lab day. And well, that's about it. I don't think I'll say any more. If I make the video too long, YouTube won't let me put it up there. So I think that's enough to get yourself going. One thing that I would encourage you to do, and I meant to look it up, but I didn't, but look in your textbook, the textbook from your lecture, and look up a little bit about friction, about kinetic friction, about what the friction equation looks like if you have two things sliding against each other. You might find that quite useful for lab day. Other than that, I am going to let you go, and I'm going to go and put this up on D2L now. So I will see you guys a little bit later.